Everybody, welcome to the Chapter 11 review, our second to last chapter. And this one was about measuring length and area. And here are your keys to success. Okay. First, know what the apothem is, and we'll look at that in a second. Second, know how to find the arc length. So here are the formulas right here, and there's two of them. You can do it either this way or you can do it this way, whichever the problem calls for. So it really is up to you which one you want to use. But some problems it'll be easier to use one, other problems it'll be easier to use another. Okay, this is super important. Know that the measure of an arc is equal to the central angle, and the measure of an arc is equal to 2 times the angle, whose vertex is on the circle. So this is what you need to remember. So when you have two lines out from the middle, so you have an arc here, okay? The measure of this arc is going to be the same as the measure of this angle. So if this angle is 10 degrees, then this arc is going to be 10 degrees. That's because the vertex of that angle is in the center of the circle. Okay? When the vertex of the angle is on the side of the circle, okay, the measure of the angle is, the measure of the arc is twice the measure of the angle. Okay, that's because the vertex is on the edge of the circle. Okay, don't forget that. That can really trip you up. It's a simple thing. Write it on your notes so you have it in the finals. Okay, know how to find area and circumference of a circle. We'll go over that. Know how to find the perimeter and area. Perimeter and area. Please know the difference between those two. Of rectangles, triangles, kites, trapezoids, parallelograms, and n-gons. And it sounds worse than it is, but you already know most of those. And know how to find the area of a sector. Okay, so the formulas for the area of a sector kind of look similar to the formulas for arc length. And there's a reason for that, but we don't need to go into it. But remember that you can use either of these depending on how the problem is worded. So, and remember, this is an or. You don't have to do both. Same thing here, or. So you can figure it out either way you want, and if you can use either formula, and if you set it up and do your math right, either will be right. Okay. So let's get started on some problems. Sorry about the blurriness, so the first question is just a simple definition of an apothem, but you got to make super sure you know what the apothem is. So remember, here's your circle, kind of a yucky circle. Okay, so let's look at some of these that are wrong, because you already know that A is the answer, but let's look at why the others are not the answer. Okay, so D says central angle of the polygon. Well, the central angle of the polygon is right here. Okay, that's number D. That's obviously not the apothem. Okay, C is the arc length intercepted by each side of the polygon. Okay, apothem of a regular described in a circle. Okay, so here's your polygon that's inscribed in a circle. Okay, what C is saying is these arc lengths intercepted by each side of the polygon. Okay, that's those. And then clearly that's not it. Okay, D's not it, and C. B, center of the polygon, obviously not it. So you could have really gotten this right just by the process of elimination. But it's pretty clear that the distance from the center to any side of the polygon, distance from the center to any side of the polygon. Okay, so this is an apothem, this is an apothem, this is an apothem, and this is an apothem. Okay, and you will use this a lot on these problems. So make sure you understand exactly what it is. Okay, find the length of arc PQ to the nearest hundredth. Okay, so we're just going to take out our handy-dandy formula that says the length of PQ, arc PQ, divided by 2 pi r is equal to the measure of PQ over 360. So remember, we're looking for length, and so length is what's missing. Okay, we should know the rest of this. So it's going to be equal to, okay, the measure of PQ. So arc PQ is right here. The center of the angle is in the middle, and the angle arc is, or the angle is equal to 110 degrees, and so the measure of the arc is going to be 110 divided by 360. Okay, and that's going to be equal to the length of PQ over 2 pi r. So we're going to cross multiply, and so we're going to have 360 times the length of PQ, okay, there's my cross right there, is equal to 2 pi r, and our radius is given as 4. Here's our radius. Okay, times, okay, the measure of PQ, okay, which we know is, let's go ahead and put the value in for that, times 110. Okay, so in order to figure out the length of PQ, we need to isolate it, so we're going to divide both sides by 360, and we get is the length of PQ is equal to 2 pi times 4, which is equal to 8 pi. Pi times 110 divided by 360. Okay, and if you work all that out, this is equal to 7.68. So the arc length of PQ, okay, is equal to 7.68 inches. Okay. Okay, find the circumference. So what is our formula for circumference? Circumference is pi d, where d is diameter. So unfortunately here you don't have a diameter. And in the picture, diameter would look like that. You do have this radius, okay, but they don't tell you how long it is. So it's going to be a little bit trickier to find it. But let's look at what you do have. You do have the arc length. Of arc LM, okay, and you know the measure of angle LM. So it looks like you can use that arc length equation to find out what the circumference is. So if we use arc length of LM divided by 2 pi times the radius, which is what we're looking for, is equal to 160 divided by 360. We cross multiply. We get 360 times the arc length, and we know the arc length is 42. That's 360 times 42 is equal to 160. There's the cross going that way, times 2 pi r. So we know that pi, we just substitute 3.14, and now we have to solve for r. So if we solve for r, I'm not going to go ahead and do the math, otherwise this will take forever. R is equal to 15.05. So the diameter is equal to 2 times r equals 30.1. And what we're looking for is the diameter, or sorry, the circumference, which is pi d. Okay, and that's equal to 94.514. So our answer is B. Okay. Okay, find the area of the figure rounded to the nearest hundredth. Okay, so there's actually 2 figures in here that we know how to deal with. Okay, and there's a triangle here. Okay, and then there is a half circle there, and we're looking for area. So let's do one at a time. Let's do the triangle first. So you know the area of a triangle is equal to 1/2 the base times the height. And by just reading the numbers, you know that that's equal to 1/2 times 16. Okay, because remember this 8 is only for half. So the whole base of that triangle is going to be equal to 16. Okay, times 28. That's equal to 224. Okay. So now I need to find the area of the half circle. And we know that the area of a circle is pi r squared. And so a half circle is going to be 1/2 pi r squared is going to be equal to 1/2 pi, and the radius is 8, so that's going to be 64. So it's equal to 32 pi. Okay. And which is equal to about 100.48. And remember, we need to add those two together. So 224 plus 100.48 is equal to 324.48. And looks like C is a good match. Remember, don't worry about those numbers to the right of the decimal place. That has to do with how we rounded pi. And so worry about the big numbers, not the little numbers. Okay. Okay, area of the kite. So area of a kite. If you look in your formulas, okay, is equal to 1/2 times D1, D2. Now what's a D? A D is a diagonal, okay? So here is, we'll call that one D1, and we'll call this one D2. Okay, so D1 is clearly is equal to 10 plus 4. Okay, that's that length right there. So it's equal to 10 plus 4 equals 14. Okay, and of course D2 is equal to, we don't know what D2 is equal to, right? So let's try to figure it out. So what the easiest thing to do would be to take this big triangle, okay, and we're going to divide it into two. Let's say we'll do this triangle right here, okay, and so that is going to be this triangle right here. And we know that hypotenuse is 5. Okay, and we know that from this, that this is a 4. Now, if you remember that one of the right triangles is a 3, 4, 5 triangle, you know right away that this is equal to 3. Okay, you didn't even have to do any math if you remembered that fact. Okay, if you didn't, then you would have to use Pythagoras, and you would say a squared plus 4 squared equals 5 squared. And you work all that out, and you will also find that a is equal to 3. So you could do it either way, and you'd be fine. Okay, so now you know D2 is equal to 3 plus 3 equals 6. So you add the two areas together, 14 plus 6. Oh, sorry. What am I doing? I have to apply D1, D2 to the formula. So 1/2 D1, D2 is equal to 1/2 times 14 times 6. And that is equal to 42. And here we've got C, 42 inches squared. So you see, you kind of had to take it apart. That first diagonal was really easy. The second one, you had to take it apart and figure out what those individual lengths were or are. But using Pythagoras, or using your memory about a 3, 4, 5 triangle, it actually was pretty easy to solve. Okay, areas of trapezoid. So we know area of trapezoid, area of trapezoid is equal to 1/2 the height times B1 plus B2. Okay. So let's look at number 1. So I have area is equal to 1/2. Okay, my height, h, is going to be the height of the trapezoid, which is 10. My base 1 is 6, plus my base 2 is 12. Okay, and if we work that out, that is equal to 5 times 18, which is equal to 90. Okay, and that, sure enough, that's what we got. Okay, this other one is also pretty easy. We have 1/2. We have the height is 8. I have my two bases, 14 plus 5. Doesn't matter what order you add those in. Okay, that's going to be equal to 4 times 19 equals 76. And there we go. Okay, So those guys are pretty easy. They're just a little review of a trapezoid. Okay, circumference. So again, just like we talked about in that other problem, the circumference is C equals pi d. Okay, so for this one, C equals pi, okay, but we don't have a d, we only have an r. We only have the radius, so what do we do to find the circumference? We multiply it by 2, so it's 16 pi is 16, and my answer is 16 pi, which is equal to, put that in the calculator, it's 50. I got 24, or it could be 27. So again, don't worry about those numbers. Okay, number 2 is even easier. C equals pi, your diameter is given. It's 13 pi, you plug that into your calculator, and that's equal to 40.82 in my calculator. So, super easy to just find those circumferences. Now, remember the circumference is this length, okay, around the circle. Okay, you're building a fence around the circle. Remember, the area is the stuff inside, but the fence around the circle is the circumference. So please don't forget the difference between the two. Write yourself a note if you need to. Okay, so here we are down on the bottom of the second page. And here's number 14. And these are a little bit trickier. So I'm going to go through them. And I think by the time I kind of get to the end of these 6, you're going to have a pretty good memory of how to do it. Okay, so how do we find the area? Okay, and in these problems, you're asked to actually to find the perimeter and the area. Come on, go back. Okay, so, and all you're given is this little radius here. So right off the bat, okay, we know that the area of a regular polygon is 1/2 the apothem A times the perimeter. So in order to figure out the area, we are going to need to figure out the perimeter. So, but how do we do that? So as I'm sure you can guess by now, okay, you have to draw a triangle. And we don't know we know that this is a right angle. Okay, we don't know what any of these other angles are. So how do we figure that out? And what we do is we remember, hopefully you guys remember this from the homework, that you can divide a polygon, okay, into these sections, okay, and the whole way around the sections is going to be 360 degrees, and you divide that by 1, 2, 3, 4, 5, 6, and you get the measure of this angle right here, and 360 divided by 6 is 60, and you know that this green line down the middle is halfway, or divides that larger red angle in 2, so we know this angle is equal to 30. So let me draw a triangle here. So we know the hypotenuse is 8, and we know this is 30, and we know this is a right angle. So if this is a right angle and this angle is 30, what does this have to be? Obviously it has to be 60. So we've got a really nice 30, 60, 90 triangle. So if you remember your rules for 30, 60, 90, okay, if this value down here is x, the x of the bottom, okay, your vertical line B is x root 3, and your hypotenuse is 2x. So here we have the hypotenuse, but we need x to calculate the perimeter, And then we need A, we need here, we'll call this A, that's the apothem. So what do we do? So the easiest thing to do is we know that this is equal to, the hypotenuse is equal to 2x. And we know the hypotenuse is 8. So 8 is going to be 2x, and x has to equal to 4. Okay, and so now we know what x is, and we know that a is equal to x times the root of 3, so that's going to be 4 root 3. So now we know those values. So let's calculate our perimeter. So we know this little half here is equal to 4, so we know this right here has to be 8. Okay, and how many, to calculate our perimeter, we build a fence around it. So there are 1, 2, 3, 4, 5, 6 lengths of 8. P is equal to 6 times 8 is equal to 48. So that's our perimeter. So our area is equal to 1/2. Okay, our apothem here is 4 root 3, and our P is 48. So now it's just a matter of math. Okay, and long story short, okay, so let's see. You can just pop this into your calculator, and it is going to be equal to, I come up with 166.28, and that's fine. Okay. So that's how you do that one. Let's try the next one. Okay, so again, we're looking at the area of the poly is, oops. Okay, area of the poly is equal to 1/2 AP. Okay, and this time we're actually given this length here, so we can figure out the P pretty easily. So P, okay, is going to be equal to 1, 2, 3, 4, 5. 5 times 20 is equal to 100. So that was pretty easy. So I got part of the equation. Now we need to find out the apothem. So again, we don't have a whole lot of information. So we need to find the central angle. So I'll do that in a different color. Yellow shows up good. So we can find the central angle. We can divide, draw a line from the center point to each of the vertices. Okay, we have 1, 2, 3, 4, 5. Okay. We know that all the way around is 360 degrees. So we have 360 divided by 5 is 72. Okay, so we know that we're going to expand this triangle here. Okay, we know that this base is going to be half of 20. So this is going to be equal to 10. Okay, and we know that this angle here is going to be equal to 72. Now, what we need to do is find A. So what do? We only know one or two things about the triangle. We know the angle of this area, and we know this length. So you got to use trigonometry. So hopefully from last chapter you're remembering what the rules for trigonometry are. Oh, and you know what? I just forgot something. This is not 72. This is 72 divided by 2 is equal to 36. Sorry, so that's equal to 36 degrees. So it's 36, it's not 30. So this is not a 30, 60, 90 triangle, so you cannot use those rules, so you need to do your trig to figure this out. So remember our tangent of theta, which in this case is going to be 36, is equal, remember, TOA, T-O-A, tangent opposite over hypotenuse. So my opposite is 10. No, it's opposite over adjacent, sorry. And my adjacent is going to be A. So I'll work out, I need to solve for A. So I'll multiply both sides by A tan theta, and we know that theta is 36, is equal to 10. Okay? And so now we divide both sides by tan 36 to isolate A, and we have A is equal to 10 over the tangent of 36. Okay, you plug that into your calculator, and A is equal to 13.76. Okay, so my area is going to be equal to 1/2 my apothem, which is 13.76, times my perimeter, which is equal to 100. And if you pop that into your calculator, the answer will come out 688.2. Okay, they came out with 690. That's close enough at this point, because I rounded in here when I did my tangent function. Okay? So, and again, remember, if you're working this out on scratch paper, when we have long problems like this, it's a really good idea to show your work, because then I can give you partial credit. And if you make a simple little example, like over here, I made the mistake, I didn't divide 72 by 2, if I could see that that's the only thing that you did wrong, I would give you partial credit for the problem. Okay? If you didn't show your work, then all I would see on the Scantron is that you got the problem wrong, and I would not be able to give you any points for it. Some points are always better than any points. Okay, so spill your guts onto the paper, please. Okay, that way I can give you partial credit. Okay, so this could get really long if I went through each one really specifically. So I'm going to do the setup, and then I'm going to, you guys can go ahead and do the rest of it. So just like in the past, okay, here we have this line here is equal to 5. That's the only information we have. So pretty obviously what we're going to have to do is make a triangle. Okay, and so in order to do that, we're going to need to find that central angle. So central angle is equal to 360 divided by the number of sides. And here we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, and it's a septagon. Okay, it has 7 sides. 360 divided by 7 is equal to 51.43. Okay, so now we'll look at one of those little triangles. Okay, we know this length is 5. We know this is 90 degrees. Our central angle is 51.43. So we know our little angle is 51.43 divided by 2. That gives us a little angle. And that is going to be 25.71. So we know this angle here is equal to 25.71. So in this case, we have, if you look at this triangle, and with theta being 25.71, we don't have the length opposite theta, which we did in the last problem, but we do have the hypotenuse. And what we need is the apothem, which is this guy right here. So we need the adjacent angle, and we have the hypotenuse. So if you look at your rules for trigonometry, you know that sine of theta is equal to the opposite over the hypotenuse. Okay, so in this case, okay, is going to be, why did I use sine? No, 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 no. Ooh, look. Okay. Well, actually, I did it both ways. Okay, so let's figure out this guy first. So this, we'll call this guy little p. Okay, so p is equal to the sine of theta, which is equal to the opposite over the hypotenuse. Okay, because remember we need to know that for the perimeter. And opposite over hypotenuse, well, here, I'll write it down here. So the sine of 25.71 is equal to p, which is the opposite, over the hypotenuse, which is 5. And so if you solve for p, you find out that p is equal to 2.17. So this little thing right here is equal to 2.17. So my whole side is equal to 2 times that. That's a 7, by the way. 2 times 2.17 is equal to 4.34. And so this whole thing is 4.34. And we have 7 sides, so our p is equal to 7 times 4.34 is equal to 30.4, and this is what they got, 30.8, and so that's all fine. Okay, so but we're still looking for area, and remember, our formula for area is 1/2 AP. We now know our P, which is 30.4. Make a little note of it, and we need to find our apothem. So, because I'm running out of room here, okay, so I'll do the apothem in a different color. So here we have our triangle, and we found our P, which is 30.4. Okay, but now we need to find our apothem. So this is where we're going to use, what are we going to use? We can just use Pythagoras. We don't even need trig. So we know okay, so we know one side of the triangle, sorry. We know this is 4.34, right? No, it's 2.17. Sorry. Even teachers get messed up, as you guys well know. Okay, so in order to find a, all we have to do is use good old Pythagoras. So a squared, my b squared is 2.17 squared, is going to be equal to 5 squared, which obviously is 25. And long story short, you do the math, you should come up with a is equal to 4.5. So my apothem is equal to 4.5. So my 1/2 AP is equal to 1/2 4.5 times my perimeter, which is 30.4. And you multiply all that together, and I come up with 68.47. And that is good for that. Okay? Okay, so number 18. Okay, how many sides are here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a 12 gone. okay? Oh, wait, we didn't do 17, did we? Oops. Where'd 17 go? Okay, let's skip 17 for a minute. And so we know our side, one of our little sides, is equal to 5. So right away we know our perimeter is equal to 5. And we know it's a 12-gon, so 5 times 12 is equal to 60. So that's our P. So we have 1/2 A times 60. Okay, and so we're going to calculate our central angle there. So that would be 360 equals 360 divided by 12 is equal to 30. Okay. So my little triangle, ooh, we're going to like this. Okay. I guess we're not. Nope. So we made a 30, but we don't. So remember, this little triangle here is half of 30. So that's going to be equal to 15. And in this case, we don't need the perimeter. We don't need to find this anymore because we already know it. So all we need to do is find this apothem. So how do we do that? And in this case, we know that, oops, that whole side is 5, so we know that the half side, when I make my triangle, is equal to 2.5. So I know one side and one angle, so I can use trigonometry, and I want to use my tangent equals my TOA, so opposite over adjacent is equal to 2.5 divided by A. So tan 15, tangent of 15 is equal to 2.5 over A. Okay, multiply both sides by A tan 15 equals 2.8. A is equal to 2.8 over tan 15. A apothem is 9.33. So I come over here, 1/2. My apothem is 9.33. My perimeter is 60. Okay, and that's going to be equal to, my area is going to be equal to 279.9. Okay, and there we are, 279.9. Okay, it looks like I skipped 17, but that's okay. I think you guys can do it. So find the areas of the sectors. Now, remember, this is where I said you needed to use your those formulas that we talked about earlier. And our formula is the area, the sector area over pi r squared, the area of the whole circle, is equal to the measure of arc AB over 360. Okay, there's our formula. So what are we given? So given that C here is a central angle and it's 65 degrees, we know that the measure of AB is also equal to 65 degrees. So our sector area, I'm going to call it SA over pi, and we know our r is 4, so pi r squared is pi times 16 is equal to our measure of AB, which is 65 over 360. Okay. Again, we do cross multiplication. SA times 360 is equal to pi times 16 times 65. Long story short, SA is going to be 9.07. Yeah. Okay, because we have to divide by 60. So find the areas of the sectors. So this is a little bit tricky. Now this is the area of this sector, 9.07. Okay. So how can we find the area of this whole part? Well, you could go through that whole routine and figure out the measure of this whole arc and then plug that into the equation, but there's a much easier way to do it. And that is, if you take the area of the whole circle and you subtract the sector area that we just calculated, you're going to end up with this larger part. It's actually a large sector. Okay, so what's the area of the whole circle? Well, that's easy. That's pi times r squared, which is 16. And then we're going to subtract 9.07, and we come up with our answer. Okay, so 16 pi minus 9.07, if you do the math, comes up to 41.17. Okay. So that's really pretty easy. I'm going to leave this other one. The 9 is done the exact same way. So I want you guys to go ahead and do it because I'm already running really long on this video. If you have questions, you can always ask. Okay, exact area of the circle. Okay, area of a circle. Okay, they're asking for it two ways. So the exact area of the circle, okay, we know that, okay, the area of a circle is pi r squared. Okay, in this case, we know our r is 6, so our area is going to be equal to 36 pi. Now, 36 pi, when you leave pi in this form, that's a hugely long number. They haven't even found the end of pi yet. And so it'd be 3.14159, blah, 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 out for tons and tons of numbers. Okay, so we can't express that and except for just using the Greek letter pi. So we say that this is the exact answer. Okay, even though we're using a letter, it's the exact answer. Now, if I was to pop in my calculator, pop pi into my calculator and multiply it by 36, I would get roughly this answer, 113.10, which is the area to the nearest hundredth. Okay, and number 2 over here works the same way. Okay. R squared, or R is 10.5. R squared is equal to 110.5. Area is equal to 100.5 times pi. You put that in your calculator and you come up with this answer. Okay, so that's pretty easy. So that's it for chapter 11. Sorry it's kind of long, but there's a lot to do in there. And remember, please use the scratch paper and please show your work because a lot of these are going to have a lot of partial credit opportunities and you really don't want to miss those. So please work out your answers on scratch paper and turn it in with your final. Okay,